I started studying this neurotransmitter called dopamine because, first of all, it has this modulatory function, so it can really mess with you. Dopamine is like taking plastic and heating it. You can reshape it the way you want. That's what dopamine does in your brain, and it's an incredible neurotransmitter. It's fascinating. The more I study it, the more interested I become, because it influences many aspects of our behavior. For a long time, it was believed that dopamine was related to pleasure. While that view isn't entirely wrong, in reality, dopamine has more to do with motivation. There are some cool experiments that do the following. You take a laboratory animal and deplete or destroy dopamine neurons in the animal. Even without dopamine, the animal is still capable of feeling pleasure. So, if you place the animal next to a lever where it can click the lever to receive food or intravenous cocaine, it will keep clicking the lever. In other words, even without dopamine, the animal engages in that behavior to obtain a reward. However, if you move the animal just a body's length away, literally if you move it to the side, it won't walk to the lever to click it again.
Certainly, I've understood. So it lacks the necessary motivation to get there and experience pleasure?
He experiences the pleasure if he's right here. The little animal, with depleted dopamine neurons, grabs food and eats or clicks the lever to have cocaine injected into its vein. However, if you take the little animal with your hand and place it a body's length away from the lever, it no longer clicks the lever. That's because dopamine is related to reaching the substance. Dopamine is associated with when you want to seek pleasure that is outside your body. There's another very classic experiment that determined this role of dopamine in motivation, not necessarily in pleasure. It further expanded on this, and it's an experiment from Professor Schutz's group, who is a leading expert on the reward system and dopamine. He taught a little monkey to sit in a chair and taught it that orange and apple juice are delicious. First and foremost, he opened the monkey's head and placed an electrode in the nucleus accumbens, which is the reward center in the monkey's brain. This electrode can identify the neuronal activity in this region. So, when the activity in this region increases, the electrode can detect it, indicating that the animal is experiencing pleasure or an increase in dopamine. What did he observe? He gave the monkey some orange and apple juice and found that the dopamine levels in the monkey's brain skyrocketed. The animal felt pleasure. Dopamine is indeed associated with pleasure, but it's more about motivation because you can feel pleasure without dopamine. Then, he taught the monkey that whenever a little light on the ceiling turned on, it would receive juice. He recorded in the monkey's brain when dopamine increased. He observed that when the monkey saw the light on the ceiling, dopamine increased significantly in its brain. However, when it drank the juice, there wasn't as much dopamine. In other words, when the signal of pleasure arrived, dopamine surged. When it felt the pleasure and received the reward, there wasn't as much dopamine.
It's like iFood.
It's like iFood. It's like that person watching a movie and seeing someone smoking in the film. When you see the trigger, your dopamine surges, and dopamine makes you grab the cigarette and smoke. When you smoke a cigarette, there might not even be as much dopamine. So, dopamine is about anticipating the reward, not the reward itself. What happens is, dopamine and the dopaminergic system, in general, evolved in light of our evolution to live in an environment where there isn't as much dopaminergic signaling, where there isn't such an abundance of hyperdopaminergic situations as there is today.
That keeps stimulating you all the time.
So, when you open a classic neuroscience book, you'll see that they use behaviors like drinking water, eating, and sex to explain motivation, because dopamine served these functions during our evolution. Back in the caves, we woke up in the morning and had to be motivated and concerned about finding food, having water to drink, or taking care of offspring, etc. Today, we don't need to worry about these things as much. In fact, some researchers argue that contemporary society is so depressed and anxious precisely because our system evolved to care about certain things, and now we don't need to worry about so much. Generally, people have food to eat, water to drink, and shelter to sleep. The dopaminergic system was developed for an environment where you constantly needed to be engaged in seeking something. Today, many times you are at home on the couch, there's food in the fridge, water is readily available, your parents help you, and you find yourself asking, what do I do now? The dopaminergic system often drives you towards what? Sometimes in excess, it's video games, drugs. Why? Because
These things, they release a lot of dopamine.
these are hyperdopaminergic behaviors, indeed. Video games, for example, are developed to release a lot of dopamine. Sex and pornography naturally release a significant amount of dopamine. What I started to study, I began to realize that when we talk, for instance, about the addictive behavior of a person who's addicted, who is a substance-dependent individual, if you take a functional magnetic resonance imaging fMRI study and look at the brain of a cocaine user while injecting cocaine, you'll see that the dopamine binding to the dopamine receptor is lower than in a healthy person's brain. In other words, there's a downregulation. What is downregulation? Due to the constant bombardment of the system with dopamine from drug use. There's an adaptive downward adjustment of your system. So, your baseline dopamine level becomes lower. That's why you always need to keep seeking it, because your baseline is getting lower and lower, and you desperately try to increase your dopamine with the drug, but it drops even more. Our body regulates itself in this way. If you consume too much sugar, your pancreas releases a lot of insulin, and as you keep releasing pumps of insulin, your cells start developing a situation called insulin resistance. Insulin resistance is more or less why the insulin receptor moves out of the cell, and you start to lose insulin binding and glucose entry into the cell, eventually leading to diabetes. The drug in the brain does more or less the same thing. Obviously, no one here is saying that people who consume sugar are addicted to drugs. However, sugar, fat, pornography, and behaviors in general are dopamine releasers, not at a peak as high as a drug like amphetamine or cocaine, but still playing games, engaging in activities like gambling, video games, excessive social interaction when desperately seeking social approval, and consuming high-calorie foods. All of these behaviors naturally increase dopamine peaks. The secret is this. Imagine that your dopaminergic system, if it has two types of dopamine release, has a tonic release of dopamine. What is it? Your dopaminergic neurons are constantly releasing dopamine, chronically releasing it throughout the day. This varies from person to person, which is why some people are naturally a bit more cheerful or animated, while others might be a bit more depressed, possibly due to a decreased tonic release of dopamine, especially in the mesolimbic pathway, in those who are a bit below the normal mood, and an increased release in those who are a bit above. But what's the problem? Pay attention, folks. This is crucial. This tonic dopaminergic firing, like a heartbeat, maintains a basal level of dopamine in your brain all day. However, there are also phasic dopamine releases, like puff. The tonic maintains it, and the phasic happens when? When you have sex, when you need food, water, shelter, or need to escape danger. When you play video games, when you drink alcohol, when you smoke cigarettes, when you watch pornography, when you consume sugary drinks, when you eat high-calorie food. These are phasic dopamine releases. What's the problem? The more phasic dopaminergic releases you have, the more your system regulates down, and that tonic release starts to slow down, like buff. So, if you have only pleasure in your life, in the absence of phasic releases, your dopamine levels become very low. This can eventually result in anhedonia, which is quite common in clinical settings. Patients often come saying, "Doctor, I don't know anything. I don't feel pleasure anymore. I don't feel this, I don't feel that." You check, and the person is financially stable, doing well in their career, almost financially independent, yet nothing makes them happy. You look at their life, and the person operates solely on phasic dopamine, going out with friends on Monday to play bowling and get drunk, playing tennis with friends and having a barbecue. This person doesn't live without a bit of difficulty. They don't give their parasympathetic system a break. When you take this away from them, it's almost as if a person who uses drugs becomes obviously not in the same way as a drug user, but they become anhedonic. So, a family trip to the countryside without alcohol or anything loses its meaning because their brain craves a lot of dopamine. It has become very demanding and developed tolerance.
So, does the opposite hold true? Does a person who chooses to endure more suffering help maintain this baseline a bit higher as well?
It doesn't necessarily help to keep the baseline a bit higher, but it does help the person become more capable of experiencing a lot of pleasure from simple things. And, of course, we are talking about extremes here. But our dopaminergic system wasn't designed for constant bombardment of dopamine. It can't handle that, because if you keep bombarding it with dopamine all the time, there will be downregulation of tonic releases, and eventually, you'll have more difficulty finding pleasure in simple things. So, what would be the big secret? It's what we call intermittent reinforcement. In other words, you don't need to go without phasic dopaminergic releases. Just schedule them with intervals. Create a kind of dopamine agenda, so to speak. And this applies not only to extreme situations like pathologies, depression, addiction, etc., but also to the more mundane aspects of life. Huberman mentioned, for instance, in one of his episodes that if you enjoy working out with music, you get really pumped and happy working out while listening to music in the gym. Flip a coin. If it's heads, you'll go to your workout with music. If it's tails, you won't. Your dopaminergic system loves uncertainty. Remember the little monkey I mentioned, the one with the juice? Over time, if the monkey learns that it always gets juice after the light comes on, it stops releasing dopamine when it sees the light because the reward is certain. So, the key takeaway here is, dopamine isn't about pleasure, it's about motivation. Dopamine is about the anticipation of pleasure. The little monkey that knows it will get juice when the light comes on releases a lot of dopamine when it sees the light. When it gets the juice, it doesn't release as much dopamine. Similarly, a person at home who orders pizza on iFood, when the pizza arrives, they may not be as motivated to eat it. They might even regret ordering it, thinking, "Why did I do this?" Dopamine. In other words, your dopamine has already dropped, and you're no longer motivated to eat. It was the trigger that released dopamine, and the little monkey that learns that it always gets juice after the light comes on no longer releases dopamine in its brain. Now, if you take a group of monkeys and set it up so that 50% of the time the light comes on, they get juice, and 50% of the time they don't, dopamine increases even more than before because dopamine is about novelty. Like, will I get that orange juice now that the light's on? Dopamine surges, and the monkey almost wants to jump out of its chair. So dopamine is about anticipating a possible reward that is coming. That's dopamine. What do casinos do? Casinos work very well with the dopaminergic system, especially with these intermittent reinforcements. If every time you pull the lever at the casino, you win money, it loses its appeal. Nothing motivates you anymore. Or, if you always win a reward, there's no excitement. Now, if you pull the lever and maybe get a reward, your dopaminergic system goes wild. So, putting this in practical terms, as Huberman mentioned, if you like to train while listening to music, I really enjoy training while listening to Raciones Jonga. I love listening to music while I train. It helps me a lot. However, lately, there are days when I deliberately don't listen to music. You might think, why are you sabotaging your workout? No, I'm using the dopaminergic system to my advantage.
Man, I think I noticed that. I was training regularly because I knew that particular style of music always pumped me up. After a month of training, it stopped working.
Exactly. Dopamine adapted the system. Now, if you toss a coin, if it's heads, you train with music. If it's tails, you don't. Every day you'll want to toss the coin and feel that little thrill in your stomach. Heads or tails, here it goes. And then, when it lands, you get to listen to the music, and you'll be really happy.